This video is going to give an introduction to matrices. These tables show information of items sold in two shops on several days. So what I want you to do is just pause the video and combine this information into a single table by finding the totals for each item per day. So you should have ended up with one table with the totals for each item per day. So for example, we take the 7 TVs sold in shop A on day 1 and add the 8 TVs sold in shop 2 on day 1 to get 15 TVs in our combined table. This is the start of matrices. So these two tables with this information, if we took away the row and column headers and put the number entries in brackets, we would end up with something like this. Now these are matrices. So we have a matrix to represent the items sold in shop A, a second matrix to represent the items sold in shop B, and then we've added those matrices together to give a third matrix which gives the total number of items of each item sold over the 4 days in the two shops. And all we've done is taken each number in the matrices and added them together. So the 7 plus the 8 has given us the 15, the 3 plus the 4 has given us the 7, etc. This is the method that computers use to add up large amounts of data. So a matrix is an arrangement of information presented in rows and columns, and the numbers in a matrix are called the elements. The order of a matrix is the matrix's dimensions, and we always give the number of rows first. So if the order of the matrix is n times m, n is the number of rows and m is the number of columns. And the easiest way to remember which way around this is the R comes before the C in the word matrices, so rows comes before columns in the order of a matrix. So pause the video and just have a go at writing down the order of these matrices. So the first one will be a 2 by 2 matrix. The second one would be, it's got 1 row and 3 columns, so a 1 by 3 matrix. The third one, 2 rows and 1 column, so a 2 by 1 matrix. And the last one, 3 rows and 2 columns, so a 3 by 2 matrix. So that's the order of a matrix. We can only add and subtract matrices that have the same order. So just as we did with the tables at the beginning, if we wanted to add matrix A and matrix B, we're just going to add the corresponding elements together. So 5 plus 8 would give us the 13, 7 plus minus 2, the 5, 4 plus 0 gives us 4, etc. With subtracting, we're just going to subtract each corresponding element in the same way. 5 take away 8 is minus 3, 7 take away minus 2 is 9, etc. We could also be asked to use addition of matrices to find unknown values. So if we had to find x and y here, well, we could say, well, the 2x plus the 3y I've got to add to equal 5. So 2x plus 3y equal 5. And then we can also say that x minus y must equal the 5. So x minus y equals 5, giving us simultaneous equations which we could solve to find x and y. And if we solve those, we find x equals 4 and y equals minus 1. We can also multiply a matrix by a scalar, and we use this with vectors. A scalar is just a constant value. We multiply each element in the matrix by that scalar. So 2a I could write with the scalar outside the matrix, and then I'm just going to multiply everything in the matrix by 2. If I want to multiply by minus 3, again, just multiply everything in the matrix by minus 3. So just to finish off, all I'd like you to do now is to pause the video and work out the answers to these 9 questions using the matrices A to F on the slide. When you've finished, you can unpause the video and the answers will be on the next slide. So here are those answers.